In this video, we're going to look at solving Pythagorean theorem problems where we have some sides that are in this a root b form. And as a reminder, the Pythagorean theorem says in a right triangle with legs a and b and hypotenuse c, a squared plus b squared equals c squared. So the type of problem we're dealing with is going to look a lot like this. And as with all of our Pythagorean theorem problems, we first should identify which side is C. So we go to our right angle, go to the opposite side, and that means that when I'm doing a squared plus b squared equals c squared, my c is going to be x. The one that's by itself with a squared is going to be the x. On this other side, it doesn't matter which one's A, which one's B, so I'll just put root 6 as A, and then 2 root 3 as B. Oop. Okay, but here's where the problem comes in. Some of you may not have dealt with squaring a square root, or squaring something in this A root B form before. So let's talk about that, and then we'll come back and solve this problem. So we've dealt with sort of an integer or a real number squared before, and we know that in this case, if I have a squared, that just means a times a. So, for example, if I had 3 squared, that would be 3 times 3, which would be 9. If I had negative 4 squared, that would be negative 4 times negative 4, which would be 16. And of course, we wouldn't see a negative 4 in this type of problem because we're dealing with side lengths, but we know how squares work in this context. Okay, now the next one. So if I had the square root of b squared, what we'll actually get is just going to be b. I'm going to put a little caveat here, so long as b is not negative. I guess it could be negative in this case, but I'm only going to deal with non-negatives because I don't want to get a complex number out of here. Now, why is that? Okay, so let me go over to some examples to show you why, then I'll come back and say why when I square a square root, I'm just left with what's inside. So, in here, some examples. If I had the square root of 7 squared, we know what that should be based on my rule. I'll get back to that. But I can think of that as the square root of 7 times the square root of 7. And since both of these 7's are inside the square root, I can multiply them together, get the square root of 49. And the square root of 49 is, of course, just 7. And that works all the time, so long as this input is positive. So I don't need to go through this process. If I had the square root of 13 squared, go through the process, I would just get 13. If I had the square root of 168 squared, that'll just be 168. The square root and the squared, for all intents and purposes in these cases where this is bigger than or equal to 0, will cancel out. So any square root squared gives me the input. They are sort of inverses. Okay, now the last case, which is a little bit harder. So if I had a root b all squared, I'll put down what that's equal to, and then we'll come back and see some examples. So the squared is going to go to both terms. So I'll get a squared, so a times a, but then root b squared is just going to be b. So I square both of them, the a gets the squared, the root and the squared sort of cancel out. And so a couple of examples there. wrong color. Let me stick to the color scheme here. So if I had 2 root 7 squared, I'll work it all the way out like I worked this one all the way out, but then we'll show some of the shortcuts. So this is going to be 2 root 7 multiplied by 2 root 7. The 2 times the 2 will give me the 4. The root 7 times the root 7 will give me root 49. But notice 49 is a perfect square, so the square root of 49 is just 7. And 4 times 7 will just give me 28. Now I don't need to go through all that process. The way I would do this is I would do 2 squared, get 4, root 7 squared, get 7, and then multiply them. So I'll go through a bunch more examples. So if I had 4 root 5 squared, I'll square the 4, get 16, square the square root of 5, and the square root and squared will cancel, so I just get times 5, and 16 times 5 is 80. Or if I had, let's say, 3 root 13 squared, I'll square the 3, get 9, square the square root of 13, they cancel, just give myself 13. Then 9 times 13, let's see, 9 times 10 is 90, 9 times 3 is 27, so I think I get 117 out of that. Okay, so with this knowledge, let's go back to our problem. I start off the same way. Find c. The c is this x, so I'll get the x squared by itself. On the left-hand side, it doesn't matter the order, so I'll put root 6 squared plus 2 root 3 squared. We just learned square root of 6 squared is just 6. 2 root 3 squared, I'll send the squared to both terms. 2 squared is 4. Root 3 squared is just 3. The squared and the squared cancel out. I do multiply this 4 and this 3 together. 4 times 3 gives me 12. So I have 6 plus 12 equals x squared. I add 6 plus 12, get 18. And then to get rid of the squared, I take a square root. And like the previous video, I'm going to get the answer in 2 forms. So one form will be the decimal approximation, which for the real world, in most situations, is what I would want. The other form is going to be the reduced radical, which as a math teacher, I prefer, and it actually does have some use in some situations. But let's go ahead and say, okay, check first of all to make sure I don't have a perfect square. And I don't, so I will write down 4.243. So x is approximately 4.243. Okay. And then the other form I need to break down. So I will take the 18 and break it into 2 times 9. 2 is prime, it does not break down further, but 9 breaks down into 3 times 3. I look for pairs. I have a pair of 3's, so that comes out. I have no more pairs, so the 2 stays in, and the exact answer is 3 root 2. Okay, let's go through 2 more examples, make sure this all makes sense, then we'll wrap this up. So, another example, I start off by finding c. In this case, across from the right angle is 7, so my c value is 7. I will have a 7 squared by itself on the right-hand side. The order here doesn't matter, so I'll make x equal to a, so x squared. And then I have a 4 root 3 squared. And I'm just going to evaluate some stuff, so I get x squared. I square the 4, get 16. Square the root 3, get 3. And 7 squared is 49. I keep going. 16 times 3 is 48. I'll subtract the 49 from both sides. Or sorry, subtract the 48 from both sides, because I want to get x squared by itself. Then I will take this, well, now I'll take the square root. I want to try to find both answers. In this case, the square root of 1 is just 1. So this is the exact solution, and I don't need a rounded solution because I already have the exact solution. All right, our last example, starting off the same way. So I go across from the right angle, and there's my c value. So I will have 7 squared by itself on the right-hand side. The order on the left doesn't matter, so I'll put root 42 squared plus x squared. I'll work this out. So the square root of 42 squared is just 42. The square root and squared sort of cancel. 7 squared is 49. I'll subtract the 42 from both sides. That leaves me with x squared equals 7. And then I'll take the square root of both sides. So my approximate answer, x will approximately be whatever the square root of 7 is, which is approximately 2.646. And then I want to get the exact answer, so I break down the 7. But the 7's already prime. It does not break down into any smaller positive integers. And since there are no repeats, everything is still stuck in the square root. So x equals root 7 is already the exact answer. So I have these two cases here. I know that was quick. If you're unsure at all about how to do any of this, I'll have a link in the description down below to a video where I solve 6 more of these problems so you can just get a feel for how to deal with this. All right.